Greetings. Today I'll be introducing math and operators in JavaScript. First, we'll start with rounding. A few ways that we could do this will be using round, ceil, and floor. Math round is how we round normally. 5 and above rounds up, 4 and under rounds down. Math ceil would round up no matter the decimal. For example, 4.2 will round up to 5. Math floor, which was different from math ceil, you'll round down no matter the decimal. Now, let's see an example. We'll first, in the HTML section, create 4 headings and 4 paragraphs. The headings will say the number generated, math round, math ceil, and math floor. The paragraphs will give IDs such as num, round, ceil, and floor. Now, starting the script section, we'll first generate a random number, and then we'll round it with the ways that we went over earlier. Then we'll use document.getElementById.innerHTML, so these results could be put in the paragraph placeholders and printed onto the screen. The number generated, let's say for short, 2.35. So when rounded, you'll round to 2 because 3 is less than 5. And then when using ceil, it'll become 3 because no matter the decimal, you'll round up. And then for math floor, it rounds down to 2 because no matter the decimal, it rounds down. In order to find the numbers of the greatest and lowest value, we can use minimum and maximum. Due to mathmin, we'll return the number of the lowest value inside the set of numbers. An example of this would be those mini golf games. To win this, the player requires to have the least move of all players. So later, when the final round was finished, when all the moves were added, we could use mathmin to determine which player have the least moves. But of course, mathmin isn't the only choice to do that. So feel free to try other ways that could lead to the same result. Unlike mathmin, mathmax will return the number of the highest value inside the set. So as an example, for those games that requires the player that have the most points to win, we could use mathmax to see which player wins and then tell them who wins. Using the previous example from rounding, we could just add 2 more headings such as mathmin and mathmax with 2 paragraphs as placeholders. After that, it's just mathmin ABCD and mathmax ABCD, and using document.getElementById.innerHTML to print these to the screen. The number generated was different from the past example. For this one, we'll just say 4.5 for short. So when rounded, it will become 5, and then using ceil, it'll also be 5. But then when using floor, it'll be 4. So due to this, mathmin returns 4 as the smallest value because the number generated 4.5 and rounded using math floor becomes 4, which is less than 4.5, and it has the lowest value of all numbers in the set. And then mathmax returns 5 because when using round and math ceil, it rounds up. So due to 5 inside the set of 5, 4.5, and 4 is the greatest value, 5 was printed onto the screen. A few things that we could do with numbers would be truncation, sign, absolute, and random. Math trunc will return the integer part of the number, which means for 3.1415, you'll return 3. Math sign will return things like 1, 0, -1 to show if the number is positive, 0, or negative. Math absolute will return the absolute value of the number, which means the number being returned will always be positive. Math random will randomly generate a number from 0 to 1. The number being generated could be 0.999 continuously, but it'll never go up to 1. And then for the number being generated greater than 1, we'll just need to multiply it with a number. And then if we don't want the decimal, we could just use math round, math floor, or math seal. Now coming to the example, we'll have 4 headings. For the first heading, math trunk, we'll have 2 paragraphs, one for positive and one for negative. For the second heading, math sign, we'll have one for positive, one for 0, and one for negative. And then for our third heading, math absolute, just like math trunk, we'll have 2, one for positive and one for negative. And lastly, for math random, we could just have one just to show a number being generated randomly. Now coming to the script section, for math trunk, we can use positive and negative 1.56. For math sign, we can use positive and negative 5 and 0. For math absolute, we can use positive and negative 5.4. And for random, it would just be a random number without being multiplied with any other numbers. Well, in this example, the part document.getElementById was coded before the numbers, but the numbers I said a few seconds earlier is what will be on the screen. So let's just say after deciding the numbers, we could just use document.getElementById.innerHTML to put these in the placeholders and print them onto the screen. The number we used for truncation was 1.56 and negative 1.56. So when truncation only returns the integer, the outcomes will be 1 and negative 1. For signs, we've used 5, 0, and negative 5. Since sign determines if the number was positive, 0, or negative, the numbers being returned was 1, 0, and negative 1 due to 5 is positive, 0 is 0, and negative 5 is negative. For absolute, we've used 5.4 and negative 5.4. So due to absolute returns the positive value of the numbers, the two outcomes are both 5.4. For random, due to we didn't multiply the number being generated with any number, the outcome is 0.06, which was less than 1. To find exponents and radicals, it could use power, square root, and cube root. Inside the parentheses of MathPal, it goes by x to the power of y. For example, MathPal parentheses 2, 3 means 2 to the power of 3. Math square root will return the square root of a number. So in my opinion, this kind of works in the format of a radical. What I mean by this was the math square root part would be the radical, and then the number that goes inside the parentheses and inside the radical would be the number that we're square rooting it. Math cube root will return the cube root of a number. For example, if it was math cube root 27, it'll return 3. In this example, we'll have 3 headings, which is MathPal, math square root, and math cube root, also with 3 paragraphs as placeholders. After the HTML section is finished, now when coming to the script, we could use 3, 3 for MathPal, 16 for math square root, and 27 for math cube root. After deciding the numbers, we could use document.getElementById.innerHTML to print this to the HTML page for us to see. As expected, 3, 3, which means 3 to the power of 3 will return 27. The square root of 16 is 4, and the cube root of 27 is 3. Now let's have a challenge. So try to replicate this calculator that have the basic numbers 0 to 9, including a decimal point. Add, subtract, multiply, divide, something to the x power, square root, cube root. The ways of rounding such as round, ceiling, floor, and then with addition of absolute and truncation. Oh yeah, don't forget to include a clear and equal button. Now coming to the signs, we could add with a plus, subtract with a minus, multiply with an asterisk, having the exponent or like showing exponents with 2 asterisks, and divide with a slash. Let's see examples now. We'll have 5 headings and 5 paragraphs. The 5 headings will be addition, subtraction, multiplication, exponent, and division. This time, in the heading, we'll also have parentheses with numbers on the inside to show or to remind us which equations we use with the signs. So for addition, we'll do 2 plus 4. Subtraction, we'll do 2 minus 4. Multiplication, we'll do 2 multiplied by 4. Exponents, we'll do 3 to the power of 3. And division, we'll do 2 divided by 4. Now, as we calculate these and print it onto the HTML, using document.getElementById.InnerHTML, we'll see the answers that we're expecting to get. As shown here, 2 plus 4 is 6, which was correct. 2 minus 4 is -2. 2 multiplied by 4 is 8. 3 to the power of 3 is 27. 2 divided by 4 is a half, which is 0.5, which were all what we're supposed to be expecting. So now let's move to signs, which we have increment, which we use a plus plus, decrement, which we use a minus minus, and modulus, we use a percentage sign. The reason why this section was named signs was because plus, minus, percentage, asterisk, slash were all signs or symbols depending on what you call it. When you say increment, you'll be associated with a counter. The reason for this was so the person could keep track of their counts. Due to increment increases by 1 each time. For this example, we'll use I as a counter. So we first set I to 0 and then create a for loop. In the for loop, if I is greater than 0 but less than or equal to 10, then I plus plus. Now, as we show it in the console log, which we open up here, we could see that 0 is counted to 10, increased by 1 each time. Just like increment, decrement could also use a counter. It's just decrement will decrease by 1 each time, unlike how increment would increase. For this example, it will be very similar to the example for increment. So we'll first start with setting the counter as 10, then creating a for loop saying I equal to 10 and I is greater or equal to 0, then I minus minus. Then again, we'll print this to the console log, so when we open it, we could see that 10 is decreased to 0 one by one. Modulus will return the remainder of a division equation. This time, we'll have one heading and 2 paragraphs. The reason for this was to show that what would happen if there is no remainder and what if there is a remainder. So first we'll start with 8 divided by 2, and the next one we could use was 8 divided by 5. Now after deciding the equations, we could use document.getElementById.innerCML so that we could print these two answers to the screen for us to see. So for the first example, 8 divided by 2, the reason why it returns a 0 because it's a perfect division, there's no remainder. So the second number, which was 3, was due to we could only fit one 5 into an 8. So due to that, there's a remainder of 3. And modulus is just a way that we could use to find remainders. So the remainder 3 from 8 divided by 5 was printed to the screen as an answer. Now let's have a challenge using increment. Create a number guessing game that asks the player to guess a number from 1 to 5 that the computer generated. If the player guessed incorrectly, have a message that prints the player was wrong, the number the computer generated, and try again onto the screen. Starting from 0, for each time the player gets wrong, increase the attempts by 1. When the player guessed correctly, reset the attempts back to 0 and print "Congratulations, you guessed correctly" onto the screen. Now before we end this video, let's have another challenge. This time, without an example being shown on the screen, let's improve the number guessing game. Let's use decrement to limit the amount of times the player can play each round. For example, we could have the player have 5 lives and each time they get it wrong, they'll minus 1 life. So when all 5 lives were lost, the player lost the game and could try again. Thank you for watching. I hope you learned something from this.